Let's quickly recap all the key points you learned about linked lists. Linked lists are the second most commonly used data structures after arrays. Unlike arrays, they automatically grow and shrink without wasting memory. But they require a little bit more memory because each node should have a reference to the next and/or previous nodes. Here's the runtime complexity of various operations in linked lists. Looking up by index or value are both O of n operations because they involve traversing the list. Inserting an item at the beginning or at the end is an O of 1 operation because we simply have to change the links. But inserting it in the middle involves a lookup, which is an O of n operation. Deleting an item from the beginning is an O of 1 operation. Deleting it from the middle is an O of n operation because it involves a lookup. But deleting it from the end is an O of n in singly linked lists and O of 1 in doubly linked lists. And that brings us to the end of this section. I hope you've been enjoying the course so far, so I will see you in the next section.